So on top of adding, subtracting, multiplying, dividing polynomials together and simplifying them, one of the big things that we'll often be doing is solving equations. And so now an equation is when we take those expressions and we put an equal sign in them. So it's equals two expressions that are equal to each other. So in the examples here, we got 4x equals 7. Or 3x plus 1 equals 9 minus x. Some expressions that are equal to each other. And we're going to want to solve these, and that means we want to find the missing value for the variable that makes it true. And we've done some of this before. We've done this with the Pythagorean theorem, and we've done some examples in previous units. So we'll go through some examples of this. We're working with a one-step equation. So we just have one thing to do, one operation to remove. You'll see things like a number plus x, a number minus x, a number times x, and an x divided by a number. So the goal here is to isolate the variable. We want to get the letter by itself, like we do when we're doing the when we're done with the Pythagorean theorem. So we're going to do that by using opposite operations. So in the example here, I got 6 times x equals 18. Well, the opposite of times 6 is to divide by 6. So I divide this by 6 on this side. That'll get rid of the 6's. 6 divided by 6 is 1, so I'm left with 1x. But we got to do the same thing on the other side. So we divide 18 by 6, I get 3. And then something similar to what we've done with Pythagorean theorem. Instead of adding, we're subtracting. We got x minus 4 equals 3. And we are subtracting 4, so the opposite of subtracting 4, if we add 4, we'll get rid of it. Negative 4 plus 4 is going to be 0. So we're just left with the x on that side. But whatever we do to one side, we've got to do to the other. 3 plus 4 is 7. Now, you could trial and error these. You could do these in your head, and that's great and wonderful. But if you get questions that require decimals, it's harder to trial and error those. And it'll take you longer. And well, yes, you might get the right answer. It's not worth the extra time that it takes to try and do these all trial and error. So while we keep usually some simple numbers, try and do these with the process so that when you get to more complex questions, it's easier to do them. You actually know how instead of trying to trial and error it. When you're doing any of these equations as well, solving equations, you can go back and check your answers. So you can check and see if you're right. If you're doing a test, you're like, I don't know, I think I got it right. You can actually test it out. So with our 6x equals 18, we found that x equals 3. So if I actually take that x equals 3 and I sub in the 3 for x, this should make an equal statement. So 6 times 3 is 18. 18 equals 18. That's true. That means we got the right answer. If we got something false, like 17 equals 18, then we know we made a mistake. And we can go back and try and fix that. So you can check all your answers and determine if you've got everything right when you're doing equations. And once you've found that letter, you can sub it in and see if it matches the opposite side. So, doing some practice with that. We're going to solve some one-step equations here. X plus 7 equals 11 is our first one. So to get rid of plus 7, we have to subtract 7. So x plus 7 minus 7 equals 11 minus 7. And we're left with x on this side. We're left with 4 on that side. And in the future, you might see, and because I know I do it when I'm actually doing my questions, I might not have this part here. I might know I'm just getting rid of that, so I just get rid of it, and I would write x equals 11 minus 7 and skip this extra part here. Once you're comfortable with this and you're consistently getting them right, you may feel that you can try that. But for now, while you're learning it, stick with that until you're always getting the right answer and you understand what's going on. In the next case, we got x minus 4. To get rid of minus 4, we're going to have to add 4. So we add 4 to both sides. So we're left with x on this side, and negative 2 plus 4 is going to give me positive 2. And again, I can go back and check that. Positive 2 minus 4, yeah, that's negative 2. Did that one right. Sometimes the x will be on the other side. 4 plus x. Well, that's no different. We got to get rid of this addition of 4, so we're going to subtract the 4 from both sides. And we're left with x, and we're left with 15. In the case of multiplication, 4 times x equals 20. We're going to divide both sides by 4. These 4s will divide out to 1, so we're just left with x, and 20 divided by 4 is 5. In the case of division, x divided by 5, well, we're going to have to multiply by 5. Five times 5, or 5, the times 5 divided by 5 are going to cancel each other out. We're going to be left with x, and 3 times 5 is 15. Couple things to note. Notice that I write my division with the division bar. Why? Because here it makes more sense, and it will help out as we get into some more complex questions, especially in grade 10 and 11. So do use the division bar, don't use the division sign. As well, using the brackets with the multiplications or mathematical dot, so you could write 3.5. If you write neatly, do that one. If you don't write neatly, and you might put your dot accidentally at the bottom and make it 3.5, don't. But that would be valid for that as well. Don't use the x though. I make my x's like this, and they differentiate from my time sign, which I make like that. But that looks like xx. And so what is it? If I put 3x5, is that 3x and 5, and then it's 15x? So don't use the x version. Just use your brackets when you're doing multiplication in these equations. All right, now we're going to bump up the challenge. We're going to go to two-step equations, and larger equations follow the same process, but they just require us to do those opposite operations in the correct order. And we've done this already. This is the Pythagorean theorem. We've removed the addition part, and then we got rid of the exponent part because we do the opposite operations using reverse BEDMAS. So we get rid of addition first, and then we get rid of the exponent. So in this case, we're going to do reverse BEDMAS. I'm going to show you two methods of doing this. Some people find this general method, which is kind of following what we did earlier, complex. And so I'll show you two methods, your choice of what you want to do, but your goal is to get to this method here. Okay, this is our preferred method. So we have 4 minus 5x equals 14. So 4 minus 5x, well, to get rid of the plus 4 here, this is, I know there's a minus sign here, but it's the minus 5x. This is still positive 4. So we're going to subtract 4. So 4 minus 4 gets rid of it. And then 14 minus 4 is 10. So all we've done is got rid of one step. So we do one thing at a time. And so it's not really any, it's just longer, but it's not any different than what we've been doing. Negative 5x equals 10. Well, that's just like question D from the above example. We divide both sides by negative 5. Notice I divide by negative 5. I don't switch it to positive. The opposite operation is division. So we're doing the opposite operation. We're not doing the opposite sign. We're multiplying by negative 5, so we have to divide by negative 5. And that gets us 2 when it all works out. So that's the preferred method. If you find, well, that's, I don't know, it looks confusing and you're not sure, another method you can try is called the do-undo method. I found this a couple years ago, and some people think it's an easier way to introduce this. Your choice. It's still going to be about the same number of steps, but it just shows you what's happening piece by piece. So here's how it works. Do is what you put first. So if you were going to calculate this, so pretend we're not solving it, but we're actually going to calculate it. BEDMAS says start with x and multiply it by the negative 5. So x, start with x, multiply it by negative 5. Then we would add the 4, and we would get the 14. Okay, that's the way we would calculate that. So to undo it, which is what we're doing when we're solving for x, we're going to start with the 14, do the opposite and subtract 4, do the opposite and divide by negative 5, and we'll get x. So 14 minus the 4 is going to give us 10. That 10 goes up here. 10 divided by negative 5 is the negative 2, and that's what equals the x. And if you notice, this is the same process that we did here. We subtracted 4, we divided by 5, and then we got the x. And all the results are the same along the way. Both methods work. This one is what I would prefer you to be able to do, but if you find this too difficult, you can try this one until you get the process down and you get this one going and done correctly. Now there's one more, or a couple examples, and then we'll look at one more type of multi-step equation, and then we'll be done with this section. So, solving 6x minus 2 equals 16. I'll show you both methods. So, BEDMAS would say multiply first, so we're going to get rid of the subtraction first. So 6x minus 2 plus 2 equals 16 plus 2. We're left with 6x equals 18. Divide both of those sides by 6. Those will get rid of each other. X equals 18 divided by 6 is 3. X equals 3. Check our answer. 3 times 6 is 18, minus 2 is 16. That equals the right side. We're all good. So that's the one method. The do-undo method would be start with the x. So this is do. Start with the x, multiply by 6, subtract 2, get 16. To undo that, we're going to start with equals 16 there. We're going to start with the 16. We're going to add 2, divide by 6, and we're going to get x. So the do goes this way, the undo goes that way. So starting with 16, 16 plus 2, that's going to give us our 18, just like here. Bring that up, 18 divided by 6, that's going to give us 3, just like here, and then our x, or 3 equals the x. So we get the same answer in both cases. Another example here, we got 10 minus x equals 12. So this might not look the same because there's not a number in front of the x, but this is still a multi-step equation. So again, get rid of that 10, the positive 10 first by subtracting it from both sides. 12 minus 10. So we're left with negative x equals 2. Why am I accentuating the negative? Because this is one of the most common errors students will make with this type of problem. When there's a minus x or minus 2x or whatever, they'll just, I'll get rid of the minus sign. I don't need it. You need it. It's negative x. It can't change from negative x. That negative sign has to stay there. Okay, you can't just, oh, x equals 2. I'm done. Because that's incorrect. We got negative x. Actually, this is negative 1x. If you want to be technical. And now we got to get rid of that by dividing both sides by negative 1. X in this case needs to equal negative 2. So be careful. This is negative 1. Okay, this is negative 1x. It's not just, oh, I can get rid of the negative sign. The negative sign has to stay. If we use the do-undo method, do, start with x, multiply it by negative 1, and then add the 10 and get the 12. So there's our do. If we want to undo that, we're going to start with 12, subtract 10, divide by negative 1, and get x. So there's our undo. So let's do that now. Let's do the undo. 12 minus 10 equals 2. Bring the 2 up. 2 divided by negative 1 is going to give us negative 2. Bring the negative 2 up. Negative 2 equals x. So again, we get the same answer. We can check that. 10 times negative, or 10 minus negative 2. Minus a negative is like adding a positive. 10 plus 2 is 12. Now the last type is the multi-step equation, and that's when we basically have an x or a variable on multiple sides. So here we have it on both sides of the equation, 3x plus 2 and 2x plus 4. Well, all we got to do is get the variable on the same side using those opposite operations. So what I did was I moved the 2x over. How do you get rid of 2x on this side? Well, we subtract it. I'm gonna move. Generally, I like to move everything to the left. Doesn't matter. You can move the 3x over to the right. Both methods will get you the same result. It'll just end up being a negative along the way. But it'll work out in the end. So I decided to move everything over to the left. Good practice. So I moved the 2 over by subtracting 2. 2 minus 2. 2x minus 2x gets rid of it on that side, and now we can have it on it becomes on the other side. 3x minus 2x is going to give me an x. We still have the plus 2, and we're left with a 4 over here. And now it's just a one-step equation. We subtract 2 from both sides. We're left with x equals 2. Let's try a couple examples of that. 2x minus 2 equals x plus 6. So we're going to get this x on the other side. How do you do that? We're going to subtract. I'm not going to put the equal sign in front, and we shouldn't put the equal sign in front. So we're going to subtract x from both sides. So 2x minus x just going to leave me with x minus 2 over here. X minus x just leaves me with the 6. X minus 2 equals 6. Got to add 2 to both sides. Minus 2 plus 2 equals 6 plus 2. We got x equals 8. And the next one, 4x minus 5 equals 7 plus 2x. We're going to get the 2x to the left side by subtracting 2x from both sides. So we're going to be left with 4x minus 2. X is going to give me, write it properly, 2x minus 5 still. The minus 5 is still there. And just a 7 on the other side. Now, reversing our operations here, we would start with multiplication. So reverse would be subtract the 5. So we're going to get rid of that minus 5 by adding 5 to both sides. And we're left with 2x equals 12. Divide both sides by 2. Those will cancel. We're left with x equals 6. We can even check our answers. 4 times 6 is 24, minus 5 is 19. So we sub that in, we'd get 19. 7 plus 2 times 6. 2 times 6 is going to be 12. 12 plus 7 is 19. 19 equals 19. 6 is the right answer. And we've now covered 1, 2, and multi-step equations. Again, this is the preferred method. You can try the do-undo method. It is harder to use the do-undo method when we have multi-step equations, however.